Hello! In this video, we are going to present our project that we made in the context of our data mining and machine learning class. The aim is to predict the level of French sentences going from A1 to C2 using machine learning techniques. It is therefore a multi-class classification. To carry out this task, we had at our disposal a dataset of 5,000 entries which contained labeled sentences to train our models, and then we had an unlabeled dataset and we had to predict the labels. First, we worked on this data without using any data cleaning techniques. We vectorized the sentences using TF-IDF, which is a method used to measure how important a word is to a document in a collection of documents. We used the result of TF-IDF to train some basic models starting with logistic regression. Here you can see our code. We first defined the model and chose the hyperparameters, then we created a pipeline containing TF-IDF and the model chosen. We fit, predict and evaluate the model with a function created beforehand. The results obtained are here with an accuracy of about 0.47. Then we used the k-nearest neighbors model, which stores all available cases and classifies new cases based on similarity measures. Again, you can see our code. The procedure is the same as before. We had an accuracy of about 0.32. We used the grid search method to tune the hyperparameters of our KNN model. This is a hyperparameter optimization technique that systematically trains and evaluates the model using a grid of different hyperparameter values and combining them to find the best combination. So here we define a grid of different hyperparameter values, then we define our model and we get the results. Then we use the optimal combination of hyperparameters and we define our model, the pipeline, and we fit, predict and evaluate it. We have an accuracy of about 0.35. Then we use the decision tree model. Here you can see our code. So, as before, we define the model, we create the pipeline, and we fit, predict and evaluate the model, and we have an accuracy of about 0.29. We also tried optimizing the hyperparameters, so we found the hyperparameters, we defined the model again, the pipeline, and we fit, predict and evaluate the model here. And we have an accuracy score of about 0.30. Then we used the random forest model. So here again we did the same procedure as before and we got an accuracy score of about 0.41. We also tried other models and we tried combining different models together, but it did not give better results. In this table you can see all our results and compare them. Up to that point the best model was logistic regression with cross-validation. But we decided to change our approach and we did data cleaning and used Doc2Vec. So here we did the data cleaning. We had first to convert our sentences to lowercase and remove punctuation. We took an already existing list of stop words and we added some letters that we thought were missing. Then we removed the stop words. Here is our result. So the sentences are indeed without stop words.
And then we used Doc2Vec. It's a machine learning algorithm that is used to generate numerical vectors from documents. You can see the code there. And then we generate some bag of words and we separate the dataset in an adapted format. And after using again a logistic regression, we used a radically different method by using a BERT. We choose the pre-trained model named Camembert, which is adapted to our task. Well, and now let's have a look at the implementation. Here we have prepared the data in a suitable format. We transformed the data frames into datasets and we did it twice. First we did it for the test data and then we also did it for the prediction data, as you can see there. And then the data are put in their respective data loaders. After that we declare the model with the set Camembert base and we declare a checkpoint that the model needs. The model is pre-trained on the set Camembert base. There are other sets, but they did not give us better results, so we use this one. Finally, we predict the results with this model. The accuracy varies from time to time because the data are shuffled. This model gave us the best results, and after all, it was a great project and we had a lot of fun doing it.